Space colonization, navigating the challenges ahead. Title: Space colonization, navigating the challenges ahead. Introduction. Space colonization has long been a subject of fascination and intrigue for scientists, dreamers, and humanity at large. Exploring the possibilities of inhabiting other celestial bodies has captured our imaginations, but it also poses numerous challenges that must be overcome. As we venture into the realm of space colonization, it is essential to evaluate the obstacles that lie ahead and devise strategies to address them. This article will examine some of the key challenges and discuss potential solutions. 1. Distance and isolation. One of the most significant challenges in space colonization is the vast distances involved. Astronauts venturing to other planets or moons will face extreme isolation and limited contact with Earth. This distance poses several issues, including communication delays, prolonged space travel, and the psychological impact of isolation. To address these challenges, advanced communication technologies must be developed to minimize communication delays. Additionally, long-duration space travel necessitates advancements in propulsion systems, life support systems, and self-sustainability strategies. Furthermore, psychologists and scientists need to study the impact of isolation on human mental health and develop ways to mitigate the potential risks. 2. Resources and sustainability. Establishing sustainable colonies in space is critical for long-term success. When colonizing other celestial bodies, such as Mars or the Moon, access to essential resources becomes a vital consideration. These resources include water, food, oxygen, and energy sources, all of which are fundamental for human survival. To overcome this challenge, pioneers of space colonization must focus on resource utilization and management. Additionally, long-term sustainability requires innovative recycling systems to minimize waste production. 3. Housing and infrastructure. Building suitable habitats and infrastructure in space is crucial for colonization efforts. Unlike Earth, space lacks the life-supporting features we naturally rely on, such as breathable air and protected environments. Establishing habitats that can sustain life in space's hostile conditions is essential. In response to this challenge, scientists and engineers need to develop robust and scalable architectures for space habitats. These structures must provide protection against radiation, maintain temperature and pressure, and foster a healthy environment for humans. Innovative construction methods, like 3D printing using in situ resources, could significantly aid in overcoming this challenge, making building in space more efficient and cost-effective. 4. Health and medical concerns. Space colonization brings with it a host of health challenges for astronauts and future space colonists. Addressing the health concerns of space colonists requires a multifaceted approach. Onboard medical facilities and equipment must be equipped to handle emergencies and provide necessary medical care. Researchers should focus on developing countermeasures and therapies, such as exercise regimes and pharmaceutical interventions, to mitigate the effects of zero gravity on astronauts' health. Long-term studies on the physiological and psychological effects of living in space can provide valuable insights into adapting to the challenges of space colonization. 5. Legal and ethical considerations. As space colonization becomes a reality, legal and ethical questions arise. Issues such as property rights, governance, and environmental impacts must be addressed to ensure responsible and sustainable exploration and inhabitation of different celestial bodies. International collaboration and the formulation of legal frameworks are necessary to regulate space activities and ensure fair resource allocation. 6. Economic viability. The economic viability of space colonization is another critical factor to consider. Establishing and maintaining colonies in space requires significant financial investment. It involves the development and deployment of advanced technologies, transportation systems, and infrastructure. To ensure economic sustainability, space colonization efforts must explore potential revenue streams. This could include activities such as space tourism, asteroid mining, scientific research, and satellite deployment. 7. Interplanetary and interstellar travel. While establishing colonies on celestial bodies like Mars or the Moon is a significant milestone, the ultimate goal of space colonization is interplanetary and interstellar travel. However, this presents numerous technical challenges that must be addressed. Developing propulsion systems capable of achieving faster-than-light speeds or reducing travel times between distant planets is crucial. Scientists and engineers are continually researching and innovating in areas such as ion propulsion, nuclear propulsion, and breakthrough technologies like warp drives. Advancements in these areas will be essential for making interstellar travel a reality and expanding our reach beyond our solar system. 8. Cultural adaptation and diversity. As humans venture into space and establish colonies on other celestial bodies, cultural adaptation and diversity become important considerations. Cultural norms, traditions, and diversity are essential aspects of human society, and preserving them in space colonies is vital. Space colonization efforts must prioritize the inclusion of diverse perspectives and cultural practices. This can be achieved through international collaborations, shared governance structures, and creating inclusive environments that value and respect the cultural backgrounds of all colonists. Embracing and appreciating cultural diversity can enrich the experiences of space colonists and promote unity among different groups. 9. Environmental impact. Space colonization has the potential to impact the environments of celestial bodies. As humans establish colonies, it is essential to minimize any negative impact on these environments and preserve their scientific value. Environmental management strategies must be developed to regulate human activities and prevent contamination or destruction of unique ecosystems. Strict protocols for waste management, resource extraction, and construction practices should be implemented.